Cool. Hello and good day, everyone. This is the Academic Fringe Festival, and we're running towards the fag end of our first edition that's on crowd computing and human-centered AI. And we have a wonderful person with us today to take us through, and it's Nithya Sambasivan, who's a staff researcher at Google Pair, and she leads the HCI AI group at Google Research India, Bangalore. And her current research focuses on using HCI techniques and developing responsible AI in India with a focus on marginalized communities. And she regularly publishes in the fields of HCI, ICT development, and privacy or security. Her longstanding research agenda has been on HCI and underrepresented communities in the global south. Nithya is a PhD in informatics from University of California, UC Irvine, and she has a master's in HCI from Georgia Tech. So I can't think of many better people who can join us today to shed light on HCI for responsible AI in general, but particularly in the global south. Thank you so much for taking some time to be here with us today, Nithya. And without further ado, I'd like you to take it away. Thanks a lot.
Thank you, Ujjwal. Thanks for this opportunity and for organizing this amazing talk series. And it's great to meet all of you. My talk today is about using human-centered techniques and methods in developing responsible AI for emerging AI technologies in the global south. And I'm like Ujjwal mentioned, I'm at Google Research, and I go between the worlds of people and AI research, team called Pair, and an HCI group that runs out of the premises of Google Research India, which is a new lab that started about a year ago. So the motivation for my current focus on algorithmic technologies comes from two different perspectives. So one is that of how over 80% of the world's population lives in what we call as the global south, right? So the countries that are basically the post-colonies in today's world. This is where we see the bulk of humanity, but we also see that there is very rapid adoption and integration of technology. But at the same time, technologies that are deployed in the global south tend to come from largely the Silicon Valley with assumptions and biases that emerge out of Silicon Valley, right? So the global south tends to have limited representation because of issues like low costs and policy infirmities and so on. And so we see a certain notion of double standards here. And another motivation comes from the fact that today AI systems are being deployed in every aspect of human existence, and increasingly in high-stakes domains that are challenging for even governments and civil society to tackle. But with this ubiquitous presence of AI, it's completely inadequate to measure the impact of these systems or the performance of these systems through metrics like accuracy, when really they're impacting some pretty fundamental aspects of planetary existence, right? So we really need to go beyond system level metrics to understand and innovate on other impacts that are being caused by AI-based systems. And this is also a field where there's tremendous hype and glamour, and increasingly nations are being called as AI superpowers. It's being used to differentiate economies. And we even see troubling trends like plagiarism. And I'll touch upon a bit of this in one of our talks. But how do we really create the right vocabularies, measurements, instrumentation to understand and to build and to architect these systems so that they can have the positive impact that we would like them to. So what does it look like to build AI systems from first principles, going from automation first, opaque, disempowering, Western to humans first, with human agency at the center of it all, participatory, and going towards a model of pluriverses, right, where multiple universes can coexist in one planet. And so this has been the focus of me and my teammates as we use human-centered techniques to build equitable AI systems with a focus particularly on India and APAC countries. There's three main areas where our research is focused. One is that of data, and others that of fairness, and others that of, and finally that of enhancing human agency in automated systems. So in today's talk, I'm going to present to you some recent work on algorithmic fairness in India, downstream data cascades in AI systems, and counter abuse and privacy when centered in South Asia. So let me start off with algorithmic fairness in India. So this particular project was done in collaboration with my other colleagues at Google, Erin Arneson, Ben Hutchinson, Tulsi Doshi, and Vinod Prabhakaran. So conventional algorithmic fairness makes several assumptions based on Western institutions and subgroups and infrastructures. If you look at a canonical example of success in algorithmic fairness, facial recognition, where there have been bans and moratoria as a result of research in the community, if we examine that, there's a number of different factors that came in place. Decades of scientific research focused on Western populations that led to subgroups and measurement scales for subgroups. Even if they work imperfectly, there's still the scientific empiricism. Public data sets, APIs, and information acts for researchers to be able to scrutinize and analyze model outcomes. An ML research community and tech industry that is fairly responsive to biased reports from end users and civil society, government representatives that are pretty clued in to technology policy, and an active media, especially investigative journalism, that systematically scrutinizes AI impacts and widely reports on them. Now, we argue that assumptions about the relevance and efficacy of these factors may fail and can even be harmful in much else of the world. Fairness research remains rooted in Western concerns and history with subgroups like race and gender, data sets like ImageNet, measurement scales like the Fitzpatrick scale, and legal tenets drawn from US civil laws. But a West-centric view could perpetuate the historical biases that algorithmic fairness purports to mitigate. And if, as AI grows in every aspect of our lives, algorithmic fairness surely follows. And if algorithmic fairness is to serve as the ethical compass of AI-based systems, it's important that the field itself recognize its own defaults, biases, and blind spots. So the questions we ask are, can fairness have structurally different meanings in the non-West? Could fairness frameworks that rely on Western infrastructures be counterproductive elsewhere? And how do social, economic, and infrastructural factors influence algorithmic fairness? So to answer these questions, we focus on India, the world's largest democracy, a multi-ethnic, multilingual post-colonial nation, and the world's second largest internet using population. Now, despite the advance of high-stakes AI developments like predictive policing, facial recognition in law enforcement, there is no substantial responsible AI research or policy enforcement in India. So our method involved a combination of qualitative interviews and discourse analysis. So through expert interviews with India-based scholars, that is scholars scholars and activists with a focus on marginalized communities in India across law, journalism, public policy, computer science, political sciences, and human rights, such as LGBTQ rights and disability rights. That being one corpus of data, and another being a systematic analysis of emerging algorithmic deployments in the past 11 years, which is since the advent of a unique ID system called Aadhaar, and examining the tech policy and the research based on these systems. This serves as the data sources for our findings. So one of our key arguments is that the distance between models and disempowered communities in India is large. And these distances can happen through technical distance, social distance, ethical distance, temporal distance, and physical distance. And so a myopic focus on simply localizing fair models for the Indian context, say, for example, by simply changing the subgroups, can backfire. And I think this will become more evident as I go through our findings. There's three main themes that we see that impacts and actually leads us to challenge conventional assumptions in algorithmic fairness. So one is that of data and model distortions. So there is an implicit notion in algorithmic fairness that if you fix the data, you fix the bias. However, social contracts and infrastructures in India challenge the assumption that data sets are faithful representations of people and phenomena. Data can be missing in the form of digital divide. Only half of the population of India has access to the internet. As a result, any digital data is a representation of the privileged. Data can happen outside of network infrastructures through off-data practices, say through phone calls, which does not count as a data point for online logging. And there's another prevailing assumption with respect to data sets, that is the notion of one user, one account model, right? Where a user data point can reliably correspond to an individual in the real world, but that often fails in India because of practices like shared device usage. And the final part of my talk will talk more about this particular aspect. We also see that proxies, which are commonly used in bias detection, can be similar but have very different implementation nuances. So, for example, a name is the most semantically meaningful proxy for caste, gender, ethnicity, and even class in India. Zip codes are heterogeneous in India, where you can have slum communities abutting, posh housing, unlike particularly the American history of redlining and homogeneity in zip codes. And we also find that Indic justice models, social justice models for oppressed communities like reservations or quota-based allocations present a new way of optimizing for fairness that is not simply based on equal opportunity. AI systems in India remain under-analyzed for biases, mirroring the limited public discourse on oppression. Now, the axes of oppression may also need to expand, right, including caste, tribe, religion, gender identity, ability, and poverty. So, for example, only 33% of internet users in India are women. algorithms that are optimizing for majority user groups tend to skew content towards male usage, male users' usage and preferences. So another theme is that of double standards and distance from ML makers. So whereas industry and research is somewhat responsive to user bias reports in the West, recourse and agency of Indian users, especially those disempowered by caste, religion, or gender, are poorly addressed in systems that are built by physically or culturally distant ML makers. And we find that the bodies of the oppressed caste communities, like the Dalit workers, who, for example, in sanitation work, are used as test subjects for new surveillance technologies. At the bottom right, you'll see an image of a wearable that's being deployed on sanitation workers in a few parts of India, which has cameras, microphones, and can track location. And this causes so much fear that the women workers are afraid of wearing the wearable when using the restroom for fear of snooping, or the workers wait for the wearables to die before taking the wearable home. And in terms of who is building AI for whom, we find that while India has a thriving technology industry, a large majority of this workforce actually works in the less influential, low-level AI labor. And the software engineers, that is the minority from India that build products, tend to come from privileged caste and class backgrounds. And these distances tend to limit the ability to remediate the distances in the technologies themselves, because of inadequate representation of the marginalized in who's building these technologies. And finally, we find that the AI imaginary is aspirational in India. It's often rooted in hype and promise. AI-based solutions are readily adopted in high-stakes domains, often too early. And this is because AI systems are seen as efficiency mechanisms to be able to distribute resources or to be able to identify persons and create inferences on them, but without the adequate regulation, policy, or even scrutiny from research. So for example, a facial recognition system that's used in New Delhi was reported in court to have about 1% accuracy. Now, the heuristic that's provided for automation systems or facial recognition systems in law enforcement is to have 80 to 95% accuracy. So this system has about 1% accuracy and cannot distinguish between boy and girl children. And this was used to arrest 1,100 protesters in 2020. And the statement that followed these arrests was that this is a software. It does not see faith, it does not see clothes, it only sees the face, and through the face the person is caught. But we know that the incarcerated population proxies can easily correspond to religion and caste. So in India, a vast majority of the under trials actually come from oppressed caste and tribal backgrounds, or from low-income communities, or are Muslims. And so even if one's if there are no demographic variables that are being captured as part of the facial recognition systems, but if the incarceration data is used, then obviously that corresponds to certain subgroups. AI solutions have end-to-end opacity in India. With this is in contrast to the model explainability and interpretability problem, which is that of developers or end users not being able to understand how a model came up with the inferences that it did. In contrast, we're talking about end-to-end opacity, where there is lack of transparency on the problem statement, on the data sets, on the model behavior and outputs, and the mechanisms to be able to scrutinize these. AI for social good projects often privilege certain sections of society. For example, CCTV and facial recognition is often deployed with the narrative of women's safety, because that's a pressing issue in India. But they may tend to marginalize the transgender community at the same time, and may even cause more harm. India lacks today an effective ecosystem of tools, policies, and processes that help stakeholders interrogate these solutions, which is a major impediment in ensuring meaningful fairness. Now, if you recall the facial recognition example that I gave you at the beginning, this was one of the fundamental mechanisms which allowed researchers and civil society to be able to assess facial recognition APIs. So how can we work towards a meaningful operationalization of algorithmic fairness in India? We need to go beyond window dressings of technical fairness. We need to understand and design for end-to-end chains of algorithmic power, including how AI systems are conceived, produced, utilized, appropriated, and contested in India. We call for recontextualizing data sets and models, keeping in mind Indian communities and Indian contexts. We call for empowering communities by participatorily working with them in defining and implementing fairness, and moving away from top-down and distant models. And finally, we call for building a fair ML ecosystem. It's not enough to simply do the research. We really need an ecosystem of critically conscious, technologically literate civil society, policymakers, and investigative journalists, along with the right tools for researchers to be able to assess models and their outputs. So that brings me to the end of part one of the talk. So I'm moving on to data cascades in high stakes AI. Happy to take questions towards the end, but if not, I'm looking at the chat window to see if there's anything coming up. All right, so this has a couple of, a familiar face from TU Delft. Laura Arroyo is one of our collaborators, along with various other folks at Google. So I'm shifting to talk about another aspect of AI systems that is so critical, which is data. And data determines the performance, robustness, safety of AI systems. And data can be a very expensive aspect of building AI systems. It can cost 25 to 60% of projects, but it can constitute that amount of a project's budget. Paradoxically, data is the most undervalued, and it's the most de-glamorized aspect of AI vis-a-vis new model development. Humans power the data infrastructure, but their work is often ignored. And this gets increasingly complex as AI systems are no longer about detecting cat versus dog, but are entering terrains like, is this a cancer or not? So data is often attacked as a databases, legal or a licensing issue, but we think that HCI has a prominent role to play in creating approaches and tools for recognizing the value of data. So our research involved, for the past year, we've been examining various stakeholders of the ML data pipeline, including data collectors, annotators, and ML developers and researchers. And our research has been conducted in various parts of the world, including the US, India, parts of Africa. And we've interviewed frontline workers, data annotators, and of course, practitioners from startups and research labs and industry. So we find that the data is viewed differently by different and constitutes a different meaning for different stakeholders of the pipeline. So for data collectors, data may be about reporting and program delivery, And for frontline workers who are also doubling up as data collectors, data sets are often orthogonal and sometimes even a burden to their delivery of frontline services. So often we see that because of data scarcity in the global south, data sets need to be created from scratch in many cases. And so that requires human labor often in digitizing and in collecting new data. And this work is a common model through which this work is done is through partnering with health organizations or agriculture organizations and making and through the help of frontline workers, digitizing the data from the communities. And there's very little transparency into the usage and the downstream use cases of the data that they're collecting. When it comes to annotators, data is used as a measure of output. It is used to determine compensation. But then we find that there is a complete disregard for interfaces and processes of annotators when in the real world. And then finally, for AI developers and researchers, data is the code for machine learning systems. It affects the communities that they're deploying these ML systems into, but they lack the provenance into how the data was collected, how it was labeled. And also, data tends to be undervalued when it comes to model development, as opposed to model development. So I'm just going to talk about developers and focus on a phenomenon that we call data cascades, which is compounding events causing negative downstream effects from data issues that result in technical debt over time. So we find that in our study of 50 plus AI practitioners, 92% experience at least one data cascade, and 43% experience two or more data cascades. These cascades tend to be opaque. They tend to be long drawn. Sometimes they take 2 to 3 years to even manifest, and they often manifest in the downstream in the real world of deployment of the ML systems. And they're triggered by using conventional ML practices that tend to undervalue data quality from worlds of big data in ads technology. And I'll talk to you about a couple of these data cascades, how they emerge, how they're detected, and what the effects are. But predominantly, data cascades tend to have negative impacts, including harm to communities in some cases, but in many cases, it often results in redoing data collection, in adding cost to the project, in burnout of partner relations. But then they're often avoidable by using intentional practices in the development of the pipeline. So to add some color on contextual reasons for why these data cascades occur. So in our study, we examined high stakes AI practitioners. That is, and by high stakes, we define this to mean that AI is being deployed in domains where there can be critical safety impacts to living beings. And this includes AI for social good, but not only AI for social good. It could also be in credit assessment. It could be in self-driving cars. So there's a whole wide range of domains in which we conducted our research. And we find that incentives and currency in machine learning are skewed towards models over data. But this also leads to practices like performance hacking, to increase the reported performance of AI systems without paying attention to the quality or the safety of the data that's involved, because of the present day incentives like citations, prestige, upward mobility in the ML community. We also find that there's limited data education in dealing with real world data. And today, you know, for the most interesting problems, it requires AI practitioners to actually go out and collect data and not simply use off-the-shelf data sets. But then data education does not, AI education does not cover this. It's hard to bootstrap data in high stakes domains. Often these data sets are created from scratch, and there can be geographical differences where many parts of the global south, these underlying infrastructures may not even exist and may need to be created from scratch, and AI practitioners are not trained for dealing with government and for creating the infrastructures and dealing with partners on the ground. And finally, there can be downstream accountability in impacting the communities. So there's 4 main types of data cascades that we uncovered in our research. I'm just going to talk to you about a couple of them. One is that of interacting with the physical world and the brittleness as part of that. So any AI system, when deployed in the real world, is likely to encounter drifts in the model or in the data that's entering the system. But in the case of high stakes AI, we find that there is pretty extreme brittleness in interacting with previously undigitized physical worlds. So for example, in domains like air quality sensing, ocean sensing, or ultrasound scanning, the incoming real world data can completely shift the behavior of the models. And like a camera in one of the participants that we met talked about how traffic cameras that they used in detecting road safety violations, even when they moved by a millimeter, could lead to the model's failure. And these failures, these cascades actually emerge from a conventional ML practice of using pristine training data. And lack of noise in the training data set. And this can occur in the form of hardware, in the form of environmental drifts, or even human drifts as the people that are involved in the project move. Another form of data cascade is that of inadequate application domain expertise. So particularly in high stakes domains, the data requires sense making in social and scientific contexts, where a machine learning practitioner may lack the expertise. So for example, in diagnosing whether a bone is fractured or not, in identifying whether a human being is a poacher or a villager, in determining whether a condition could lead to premature delivery of babies. And we find that a conventional ML practice of over-relying on the ML practitioner's own assumptions in these application domains can lead to limited engagement with actual domain experts, and also engaging only with domain experts in the problem statement stage as opposed to throughout the system development leads to inadequate application domain expertise. So I'm going to just briefly touch upon raters. We find that in general, from our analysis of rater interfaces, that the processes, the task design, and the UIs that are being used by raters in real production systems are meager and do not do not center the raters as being users of these systems. So although there's been tremendous research in the HCOMP community, we're yet to see a lot of this percolate into the real world systems. I'm going to skip some of this and talk briefly about data collectors just briefly. Frontline data workers tend to collect data, like I mentioned, but data collection is often a barrier. And it can even come in conflict with their primary goals, say in providing care to patients. And that can lead to not just inadequate care to patients, but also potentially data quality issues. So some provocations are to, based on our study, are to move from doing more with data to doing better with data, which really considering data as a first-class citizen of AI, because it is, and to incentivize and to value data work as part of the ML pipeline to be an important contribution to move towards rate of first designs and ethics and data collector first designs and ethics, rather than viewing the data workers as operational elements, or moving towards volume-based, moving away from volume-based work to actually quality-based work, in valuing domain expertise in every aspect of system development. And for HCI, the need to build better tools that can incorporate greater visibility in the data pipeline. We find that there are several amazing tools for data analysis, but then we lack good tools for data definition, as well as for detecting drifts when systems are deployed in the real world. And a call to action for the AI and ML community as a whole, which is to incentivize data rigor in research science as well as in practice. So for the final portion, I'm just going to briefly touch upon digital abuse and privacy. So I'm pivoting away from the world of AI practitioners into women and non-binary members. So this is these are findings that are part of a larger research project on examining gender equity online in various parts of the global South. But I'm going to focus on South Asia, and for the purpose of this study, we're limiting South Asia to India, Pakistan, and Bangladesh, which is where we conducted the research. So like I briefly mentioned earlier, there are far fewer women that are accessing the internet than there are men. The ITU reports that in 2/3 of the countries in the world, there are more men than women online. And this can be pretty skewed in countries like India, where only 33% of the internet using population is women. So online safety is one of the big barriers to women accessing the internet. And this is because consequences can be pretty severe for the communities. So on the left, we see an example of Venupriya, who was a 21-year-old college-going student in South India, whose picture was downloaded and morphed over a pornographic image and circulated virally. And ultimately, she committed suicide. On the right, we see Kandil Baloch, who was an Instagram celebrity whose own brother murdered her for posting bold posts on Instagram. So in our research, we find that there's three main types of online abuse. One is that of cyber stalking, another is impersonation, and finally personal content leaks. I don't think I'll slide here on method, but basically this work comes from interviews and a survey with women and men in various parts, in 7 different countries, but here we're limiting to 3 countries which have geographic and cultural similarity: India, Pakistan, and Bangladesh, which used to be one larger unit. And by working in collaboration with NGOs and by recruiting some of the participants, basically this data represents a broad spectrum of women and non-binary members across religions, professions, class, and geographic locations. So coming back to the abuse vectors, I'm going to just briefly talk about each of these types. So one is that of cyber stalking, which is constant unwanted attention from strangers. This can often take the form of sexualized requests like "I love you" through friend requests and through contact points. So the thing to note here is that any communication mechanism can be exploited to contact women, often in a derogatory way. We see a quote from Shanti here: "In all names are pseudonyms." On social media platforms, they'll come and say, "I love you, come with me." Recently, I posted an ad for a scooter on a classifieds app, and even there I got requests like, "Do you want to have sex?" They don't leave us alone anywhere we go. So as technology, as this rosy story of next billion users and the explosion of technology in every part of the world, this narrative takes place, we see that with new forms of technology, there's new forms of abuse. And often this can be pretty devastating forms of abuse, and that we're not, as a technology community, we're simply not paying attention and not keeping up with safeguarding the people that are coming online. So back to cyber stalking, which is unwanted phone calls and SMS. This can also take place in the form of circulating numbers. So there was an incident which you see here on the right, where a few years ago, when women would go to top up their phones on prepaid data cards in mobile shops in the north of India, the shopkeepers copied the phone numbers and sold them as packages. So anyone that was willing to pay money was offered a package of women's phone numbers. And today, with a phone number, you can create an account, you can contact somebody, you can share information with them. And what we take into consideration as ordinary units of identity, like name or a phone number or a photo or even location, and many of us may consider to be unproblematic, can be extremely problematic for women in various parts of the world, and not just for women, because these basic units can be used as entry points to attack the reputation of women. So as more and more apps are using identities like phone number-based account creation, moving away from email-based account creation, this just presents more problems. Another abuse vector is that of impersonation, which is copying a person's name or likeness without their consent. Now, one form in which this can happen is synthetic porn, which is the example of that I gave earlier of Vinupriya. And victims are not alerted by the platforms. This can take place in other third-party platforms outside of the realm of a particular platform. And this can also happen in the form of creating a fake profile, creating a false disreputable profile with the exact same details of an individual. And then finally, personal content leaks are non-consensual revelation of personal content in unwanted social contexts. And this can be ordinary interactions like friendly chats and normal innocent photos that can be turned into harmful content when just released in the wrong context. And this is, in our study, this was the most incapacitating form of abuse. So I'll give you an example of how this happened. In Pakistan, when we met with a women's safety NGO, they described an incident where a group of college-going male students had created a social media group on Facebook and had circulated the numbers and names of the female counterparts in the college. And this went on for some time. But the page was the language in the page was Pashto, which is a frontier language in Pakistan, but not a widely spoken language. And so the NGO, somebody reported this to the NGO, and the NGO stepped in to translate the content for the platform provider and reported abuse. But this took a week for the NGO to translate the content. But a week can be an extraordinarily long time in the life of somebody whose personal details are being shared online. And the staff member told us sharing a girl's picture online may not be a big deal for US people, but a fully clothed photo can lead to suicide in conservative parts of Pakistan. So what is considered ordinary just varies in different parts of the world. Context matters, and what present-day platforms consider acceptable can be completely harmful for vulnerable individuals. What happens as a result of online abuse? Emotional harm, reputation harm. So this is true all over the world, but in the South Asian context in particular, there's an increased sense of importance of a woman's reputation for the family. So destroying a woman's reputation can lead to destroying, the honor or the reputation of the community or the family. We also saw that as a result of abuse, there was domestic violence. So how did the women in our study cope with the abuse? By largely relying on friends and family. Surprisingly or not, we found that only 2% of the participants reported on tech platforms, and only 1% reported to police, because tech platforms were seen as too distant, as not even being within the realm, within the sphere of one's life, even though that's where the abuse takes place. The efficacy of these platforms was not even considered. Or that the platforms were in America and too far away to understand the notion of abuse. And with police, in our study, we found that there's inherent distrust on the state and police to protect women. And then we saw another class of practices with regards to preventing abuse, like limiting self-disclosure. This could take place in the form of using non-face photos like flowers, as you see in this picture, religious quotes, photos of pets, to prevent faces from being exploited in the form of profile pictures. So some of our takeaways are to understand and to leverage cultural relations, like the reliance on friends and family in the South Asian context for dealing with abuse, and not just imagine that people all over the world are going to report abuse simply because there's an affordance to report abuse in every platform. To work with NGOs and to consider the fact that context matters. Mildly sensitive context may be abusive in other parts of the world. So I'm going to actually stop there to allow a little bit of time for questions or discussion. And yeah, if there's time for Q&A, I can also talk about how this work has been used at Google.
That was awesome. Thank you so much, Nithya. That covered a lot of interesting areas that I'm sure are very relevant to many of us here today. I'd probably like to kickstart the Q&A by asking something before we see whether others in the audience would like to chime in. Well, you very captivatingly talked about how there's this distance between machine learning models and communities and how this can lead to an end-to-end opacity, right? I thought that was very beautifully put. I was just wondering if you had any thoughts or ideas about how this issue can be addressed.
So I'll describe the problem in a little bit more detail, and then
Sure.
proposed approaches. So we find that there's among both international and domestic machine learning makers, both private and state machine learning makers, and we don't just mean the neoliberal industry. We're also referring to the state, which is increasingly deploying machine learning. There's a perception of double standards for Indian communities, or more broadly for populations in the global south, right? So you could call this quote unquote third world standards, where because of these regulatory infirmities, intrusive models are deployed without adequate consent or attention to privacy. There's very poor recourse, especially for the marginalized communities. And I mean, the last portion of the talk actually talks about the abuse that's faced by women is how a population actually encounters the after effects of technology and lives with the consequences. So with very poor recourse. So we call for participatorily working with communities in defining problems and approaches, and really being humble in our approaches to building ML, and to provide what we call first world care for the global south, right? And so that we avoid like the Union Carbide disaster, which happened in 1984 in India, which is one of the world's worst industrial accidents. We still live with the after effects. And one of the reasons why that happened was because of double standards, right? In building the Union Carbide plant in India, with very poor safeguards for Indians, for the plant in India. So this is a cautionary note for ML to not proceed in that direction, to avoid such a disaster, and to really have these first principles built into ML systems that are likely to go global, especially in high stakes areas like healthcare.
All right. Thank you so much, Nithya. I do see that we have Eleni from the Leibniz University in Hanover who has a question for you. Eleni, would you like to unmute yourself and ask it yourself? Oh, just a second. I think all participants should be able to unmute themselves now. Just give me a second. I'll check on this.
Can you hear me now?
Yes.
Great. Thank you very much. The talk is really interesting, and I'm also very much getting to know a lot of stuff I had no idea about, and it's really nice. Also for organizing, also for the talk. I have a question regarding the AI educational data that you mentioned. Although there is a lot of online educational resources, you only mentioned that there are not so many AI educational related data. I wanted to know why you think that's that, and which are, in your perspective, the main challenges in this field.
Thanks for the question, Eleni. So what we note here is that there's been tremendous democratization of AI education, right? With nano degrees, with openly available courses for free. So there's been enormous innovation and access to learning about AI systems and building AI systems. However, a vast majority of these courses lack attention to data ethics and to creating and working with data sets, right? So beyond data analysis to, in our study, we see that there are numerous challenges that AI practitioners face when it comes to sourcing and curating their data sets, right? Which it seems like they're rather inadequately trained for. including setting up relationships with the government, going out to communities to collect the data, working with the frontline workers to provide data literacy for them, working with domain experts, understanding the what it means for a variable to be represented or not when it's particularly in a high stakes domain in a data set, understanding fairness, and then more on the downstream side, what are the impacts of the data? What does a drift mean with regards to consequences to a community, which are slightly beyond even data sets to understanding, some of the ethical impacts. Yeah, so that we see that today there's a gap in AI education with empowering practitioners to understand how to go out into the real world and collect and curate your data when data is actually a competitive advantage today. I hope that answers your question.
Guess Eleni is probably saying yes. Thank you very much. Nithya, perhaps before we wind up, unless there's a question from anyone else here, I'd like to shoot one more. I was just wondering if you could elaborate a little bit on what you meant by the conflicting reward systems that tend to lead to data cascades as well.
Yeah, it touches upon this point of a title of our upcoming Kai paper is "Everyone Wants to Do the Model Work, Not the Data Work." I think that particular quote from a participant captures the whole problem here, in the sense that there's for the AI practitioners and the researchers, there are incentives towards deploying the AI models, going against time in some cases because of funding, and to report high performing models. And for researchers, today the incentives are towards the glamour of publishing new models in research venues in AI, and like I alluded to earlier, this even leads to like plagiarism and one-upmanship and a lot of hype that's created in this whole AI space right now. That in contrast to field partners and domain experts, right? Say when it comes to AI for seismology, for earthquake detection, that's at the combination of an AI practitioner and a seismologist and their domain expertise. But the seismologist may not gain much from working with the AI practitioner in the models that we have today, unless they're made, like an equal participant in the benefits of that AI system, like being a co-author on these papers. The frontline workers have very little to gain from the AI systems to which they contribute, in that they even lack the transparency into what the data sets are being used for and why they're being made to collect data on top of their daily responsibilities. So it's not a level playing field for the various stakeholders of the AI system. And the power relations today are such that it's the researchers and the developers that stand to gain from the production and the release of these systems.
Thanks again, Nithya. That's really insightful. I'm afraid we'll have to wind up now, also not to take too much time away from your schedule. Thank you so much for being here with us again. And yeah, it was lovely having you here. I hope to see you around.
Thank you, Ujjwal, for organizing this talk, and all the technical organizers too. Thank you, everyone, for being a part of this talk.
Wonderful. I'm glad that all of you were here and joined us on this wonderful session today. And I look forward to seeing you all again at our next staff event. I'd just like to convey that we do not have a talk next week, but we do have two very interesting ones coming up the week immediately after that. So that's the 15th of February. We have Olga Magorskaya from Toloka. She's the head of Toloka at Yandex. And we also have Simo Hosio, who's an associate professor at the University of Oulu. and they're going to be talking about some very interesting issues in crowd computing and human-centered AI. I look forward to seeing you all once again there. And that's it from us over today. I'm Ujjwal Kadiraju, and this is the Academic Fringe Festival. See you again. Thank you very much.